Hello everyone. Today we are going to discuss the sixth problem of AtCoder beginner contest 330, which is minimize bounding square. So we are given n points labeled 1 to n. Point I is located at index coordinates xi comma yi. So we can perform the following operations between 0 and k times. We don't have to minimize the number of operations, but what we have to do in each operation, let's say let me take some example and this. So let's say we are at we have some points, this point, this point, this point and this point. So at each operation we can move the point towards left, towards right sorry, this is towards left and this is towards right, this is upwards or downwards. So let's say we have some point x comma y. So in each operation there will be four type of operations. So we can increment the value of x, we can decrement the value of x minus minus, or we can increment the value of y, or we can decrement the value of y. The when we are incrementing the value of x, the y will remain same. Similarly, when we are changing the value of y, x will remain same. So what we have to do after performing the operation from 0 to k number of times, we have to take one square such that all the points are covered in the square, and we have to minimize the length of the side of the square. Okay, we have to minimize the length of the size of the square. So there are few observations, right? The observations, let me write the observation. The first observation is that let's say we have after making the operations, let's say we have some x1 to xn, and we have some y1 to yn. Okay, in sorted order, you can say in sorted order. Okay, so the length of the side of the square will be nothing but maximum value of xn minus x1 and yn minus y1. Okay, that's the first observation. The one of the most important observation is this. Now the second observation is also very interesting. The second observation here is that this type of problems might be uncomfortable to some people like me, that problems involving geometry. But here you can say that the operations on x and y are independent. So we are not changing a value of x and y in each operation, in one operation, right? So you can treat x and y as a 1D plane. So we can convert this problem from 2D plane to 1D plane, considering x as a array and y as a array. And what we will do, we will try to do some operations. Let's say operation 1 number of times here and operation 2 number of times for y, such that operation 1 plus operation 2 is less than equals to k, and we will try to minimize this value, maximum value of xn minus x1 and yn minus y1. We will try to minimize this value. Okay, this is the value of side. I have already told you this. These are the two observations, most important observations here. Okay, and what is the third observation? Third observation is that we can iterate over this side, right? What is the maximum value of side? The maximum value of side is that the current positions, right? What is the current position of x and y? Okay, so let's say current maximum value of x is xn, and current minimum value is x1 and yn minus y1. This is the maximum value of side currently, the maximum of these two. Okay, so we can iterate over these side values, and let's say, okay, so we have the side value, right? We have the side value and we have some array, let's say x1, x2, x3 dot 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 xn. Now for each point we will try to figure out, if it is possible to have x2 from xi to xi plus side. Okay, if we have something like xi plus side here, this portion, and we will try to move all the points from the left side to x2, and all the points, let's consider it as xr. So we will try to move all the points from left to x2 and all the points from right to xr. So let's consider it as XL comma XR. So we are moving all the points from left to XL and all the points from right to XR. Okay. So uh, how to calculate this? How to calculate this, right? So let's say there are C1 number of points in the left. So we will have C1 times x2. We will take C1 times x2 minus, if we take the uh, prefix sum of up to x1, okay, xl. So is sorry guys. Uh, Let me make these things more clear. So we have C1 number of points up to L and R. So we have C1 number of points on the left of L and C2 number of points on the right side of R. So we'll have C1 into what we can say, C1 into XL, you can say C1 into XL minus prefix of L minus 1. Similarly, we will have plus suffix of R plus 1 minus C2 into XR. Okay, this is the function to calculate this value. Okay, this is the problem is a bit difficult and an implementation heavy. So let's go through the steps one by one. So this is the first step, how we are calculating the sum for a certain size, certain side. Okay, so what I have explained till now, let's iterate over that. So we will have some value side, and we will take x and y separately. We'll iterate over the value of side. Now we have something like x1 till xn. Now we will try to capture something like xl to xr, such that this thing is the length of this thing from xl to xr is made. So what you can say that xr minus xl is less than equals to made, and this formula we can calculate the total number of operations to achieve this, that all the values of x will lie between xl and xr is achieved by this formula, c1 into xl minus prefix of l minus 1, where c1 is the number of points on the left side of xl, and similarly plus suffix of r plus 1 minus c2 into xr, where c2 is the number of points lying right side of xr. Okay, so here c2 points and here c1 points. I hope you get this formula. Now let's jump into this. Let's say we have got this operations. Let's say we are minimizing this operation. Let's say we are getting operation 1, and similarly we will do same thing for y, and we will get operation 2, and we will check that if operation 1 plus operation 2 is less than equals to k. If this is less than equals to k, then we get our side. We will take the minimum value of side. Now what is the maximum value of side? The maximum value of side could be xn minus x1, I have already told. Now let's jump into the constants. The constants on x is 10 to the power 9, so we can't iterate over all values of side, right? So what we can do now, this function, if you check it closely, or think about this, that when we are increasing the value of side, the number of operations will decrease or remain same. So this is something like increasing function. This function is decreasing function. So with the increase in side, the total number of operations will decrease. Okay, so so what I have explained is that with the increase in side, the total number of operations, let's say t of, will decrease. So with the increase in side, the total number of operation is decreasing. Okay, so what we can do is that we can use binary search here. We can use binary search on side, on the value of side. So without further delay, let's jump into the code, and I will try to explain the things when explaining the code, right? So we first we are considering the value of x and y separately, so that's why I am sorting the value of x and sorting the value of y, right? And similarly this part is building the prefix and suffix array. We'll need this for both x and y. So prefix is x will denote prefix for x, similarly prefix y, suffix x and suffix y, right? Now here L and R we are doing binary search on the value of side, the length of the square, the side of the square. So here mid will denote the side of the square, if it is possible or not. So here this part is to correctly identify what is the minimum number of operations needed for the current value of side. For this exam will exam, what exam denotes, exam denotes what is the minimum number of operations, min ops, minimum operations for the current value side for x. Similarly y sum will denote minimum number of operations for current value of side for y. And we are taking if x sum plus y sum less than equals to k, that means the current value of side is possible. So we are taking answer as mid, and we are checking for the left side, like left half you can say. I am not going into deep into how binary search works, so I hope you understand. So this part is interesting, this part is interesting, and this some of this part I have already explained. This formula c1 into x1 minus prefix of l1 l minus 1, c1 into xl minus prefix of l minus 1 plus suffix of r plus 1 minus c2 into xr. So here another observation lies here. Let's say we have something like x1 x2 dot 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 xn. So our optimal value of this interval xl to xr will have some point, xl should be equals to xi, some value of xi, or xr should be equals to some value of xi. Okay, so what does it mean? That let's say we have we are iterating on the values of x. Let's say we are at some index xi, so we'll try to check if xi to xi plus mid is possible. This is possible. Or we will check if xi minus mid, it is not xi plus mid. Okay, xi to xi plus mid is possible, or xi minus mid to xi is possible. We'll check these two interval for every value of I. Okay, that's what I am doing here. So this part is for checking xi to xi plus mid. We are doing lower bound here. So instead of iterating over we are trying to find what is the value of r for current index xi plus mid. We will try to find the value of r. I'm not going into deep, the video will become more longer. So we are trying to find so xi would be the left index, and we'll try to find r here. Okay, similarly for this interval our xi will be r, and we'll try to find l here by doing binary search. I'm not going into deep of this. Okay, I'm very tired after explaining all this. If you have any doubt in this part, please write in the comment section. I will reply to your comment that why I am doing this thing. I hope you will understand. This part is quite simple after I have explained. If you know about C++, you will know about what I am doing here. We are just doing binary search to find the value xi plus mid plus 1. This is nothing extraordinary, right? So I hope you got it. I know this video might be not very helpful to you if you don't know C++, because I have skipped many parts of the code because the code is very longer. I don't want to go into each part of the code. Please write in the comment section if you have any doubt in any part of the code. If you find this video helpful, please like the video and subscribe to my channel. Thank you.